Hello, physics students. This is Ms. Medrano. We're going to go over one-argument functions. So you should have these two little worksheets posted in your notebook. We're going to draw a square with side lengths 2 centimeters. And so first, what we're going to do is draw a square. So square, hopefully the sides are all equal. And because mine aren't, I'm just going to label them 2 centimeters each side because I didn't have a ruler. And so now we're going to calculate the perimeter of the square, and we have to show our work. And so from what I remember, you told me that you guys learned how to calculate the perimeters in your algebra class. And so you said in class that the perimeter is just side plus the side plus the side plus the side, right? So for our square, it is 2 centimeters plus 2 centimeters plus 2 centimeters plus 2 centimeters. And that should give us 8 centimeters for the perimeter, which is the measurement of around the square. So now we're going to draw a square with side lengths 3 centimeters, and it's the same thing, right? So because I didn't have a ruler, I'm just going to go ahead and label each square side with 3 centimeters. Now, most of you in class drew it with a ruler, so thank you. But this is how I'm just going to do it to show you how I'm going to do it. All right. So now the perimeter of the square, it's the same thing, is going to be side length plus side length plus side length plus side length. And so we're going to just skip that part and do perimeter is equal to 3 centimeters plus 3 centimeters plus 3 centimeters plus 3 centimeters, which is going to give us 12 centimeters. And next, we're going to draw a square with side length of L. So L is a variable. This means that we want to draw a square for any value, right? So any number, any length. So we don't know what that length is, so we're just going to call it L. And so each side I'm going to label L. Now I don't know how many centimeters it is, it's just L centimeters. And the perimeter for the square, like how we had done it for the other two squares, is just going to be L plus L plus L plus L. So now we're going to switch over to our design recipe and kind of work through what we've done here on this side. So on the design recipe on page 1, so make sure to look at the bottom of page 1, the purpose of this function is to compute the perimeter of a square. We are going to write this into Pyret. And so we're going to just teach Pyret how to make a function. All right, and so let's see here. Okay. So we are going to design our own function, and we can call that function any name because Pyret doesn't know. We're going to tell Pyret what it's called. And so this is the part where we're learning how to write our own functions, and we're going to tell Pyret what to do and how to do it specifically. So this function will have an input. So we're going to give Pyret some sort of number, and then the function will compute it, and we're going to get an output. And based on what we had in our design recipe, our output is going to be the perimeter because that's what it says in the purpose of our function, right? So it's to compute the perimeter of a square. So we're going to put an output of perimeter and perimeter of a square. We have to be specific because sometimes it's going to be different for each shape, right? And so our input will be the side length of that square. And so if you remember, the side lengths are just how long each side is. So our example number 1 was 2 centimeters. Next, we're going to do, we're going to put the 2 centimeters into the side lengths. And when we get our output, it's going to be 8 centimeters. So we're going to tell Pyret how to take 2 centimeters into 8 centimeters. So our input will be the side length, and that's going to be in the unit of centimeters. So we'll go ahead and write centimeters for the units of each input. Next, we will have the output be perimeter, and so we're just going to write that here. And the unit of the perimeter is going to be centimeters. All right, so now we're going to go ahead and write the contract and purpose statement. The contract of something is we're going to agree to do something, right? We're going to tell Pyret this is what we're agreeing to. All right, so now that I've chosen all the colors, we are going to go down to this part where it says contract and purpose statement. So once again, contract, we might know the definition of contract is something, right? So the contract is that you agree to do something, like, for example, I had signed a teacher contract, so I agreed to do something, and then the school on their end will do something, like how you signed the academic integrity contract. All right, so for this, SQ per, we're going to name our identifier, which means the square perimeter, right? We want to give it something meaningful. And we don't want to make it too long because the point of it is to kind of give it a nickname, right? So SQ per, then we have : number. So this is the data type of our input of side length, right? So side length has a data type of number. We know that it could be image. We also know that data type can be string, just like how when we were drawing our flags. And the output, the perimeter, is also going to be data type number, okay? And so now our purpose statement, we're going to just give ourselves a note of what the function does. So the function consumes number, the function consumes side length of data type number and produces perimeter, which is also another number data type. Okay, so we'll just make ourselves a note for this. Now in the examples, we are going to give Pyret some examples of how to calculate it, right? So we're going to put our identifier, which has been written for you, of SQ per, and we're going to take the calculations that we've done from the previous page and put it into our design recipe. So SQ per of 2 is going to be 2 plus 2 plus 2 plus 2, right? We don't want to write just the answer. We want to show Pyret how we're calculating it. And now for the example, we could choose any number. So I'm going to go ahead and choose 73. Okay, so plus 73 plus 73 plus 73. So I'm basically telling Pyret, whatever the input is, I want you to add it 4 times. All right, so now my input, I will call my input L, capital L for side length. And I'm just going to tell Pyret, whatever number is in here, go ahead and add it 4 times. L plus L plus L plus L. So that's the one argument function. Let's go ahead and open up Pyret. So code.pyret.org/editor. And I'm just going to go ahead and start typing now. You can pause this video if it's going too fast. Okay, so the purpose of this function is to compute the perimeter of a square. And we're just writing what the purpose is, right? Now the contract is, we'll skip the physical interpretation. Okay, so the contract is write your identifier, space, : space, number. Make sure the N in number is capitalized, space, then dash, and then the greater than symbol, space, number. Okay, and we're going to just go ahead and write out what our contract is, which is the function consumes side length and produces perimeter. And we're just going to tell ourselves that side length is of data type number and perimeter is also data type number. All right, so next we're going to write in our examples. So go ahead and write another comment of examples. So our examples, we have to make sure that we always write it out and that we don't ignore it. Okay, so it's going to be super important when our calculations get a little bit more difficult and a little bit more complicated. So right now it looks like it's simple because it is. Okay, so SQ per, so examples, : SQ per, parentheses 2, close parenthesis, is 2 space plus sign. You need to make sure that you have a plus sign between each, or put a space after and before each plus sign. Okay, you can have as many examples as you want, or you can have like just one example. I like to give many examples so that it knows what's going on. Now this is like a question mark. It's checking if your right hand and your left hand side of the is the same. So like SQ per 2 is 2 plus 2 plus 2 plus 2. SQ per 3 is 3 plus 3 plus 3 plus 3. So it's going to check and it's going to tell us whether or not we're on the right track, right? Or if the right side and the left side don't match up to what we say the rule is going to be. Now the function definition, this is where we write what the function SQ per will actually do in Pyret. So we'll put fun, SQ hyphen per, and then L because that's our side length variable. And then same thing, we'll put L plus L plus L plus L. And we're going to put spaces before and after our signs. All right, so now this feedback is telling us that SQ per 73 needs no space. And we have 2 tests passed, but 1 test failed. So let's go ahead and take a look at what those details are. So we have test 3 failed. That's because I said 73 is 71 plus 71 plus 71 plus 71. So now I have to make sure that my right side and my left side match. All right, so now let's go ahead and run it, and hopefully it passes. And looks shipshape. All 3 tests passed, mate. And so then we'll go ahead and see if it works. So SQ per 9 should give us 36, and it does. And so let's try it again with 12. Okay, and that's perfect. Let's try it with L and see what happens. Oh, so it says that L needs to be a number, not a letter, right? So that's my bad. So now go ahead and do the second part of worksheet 4A on your own and try to complete the design recipe.